Hello students, it's me again. Today I'm going to cover the topics of network layer. Please subscribe to my YouTube channel for tips if you like this video. For today, upon completion of this lesson, which is the network layer in the OSI model, students should be able to explain how the network layer protocols and services support communications across data network. You should be able to explain how the routers enable end-to-end connectivity in a small to medium-sized business network. You should be able to determine the appropriate device to route traffic in a small to medium-sized business network. So let's jump into all these four parts. The first one, 6.1, I'm going to cover the network layer protocols. 6.2 will be on routing. 6.3 will be on routers. And the last part, I'm going to cover 6.4, which is configuring a Cisco router. Okay, this is the network layer protocols. In my previous lesson, I already covered the 7 layers of OSI model, which is start from the physical layer as a layer 1. Layer 2 will be a data link layer, network will be the layer 3, transport will be the layer 4, session will be the layer 5, presentation will be the layer 6, and the application will be the layer 7. So we have the 7 layers of OSI model, and in this topic, our focus will be on layer 3, which is this, okay? And our PDU name for this network layer will be the packets. Okay, what is the network layer? As we communicate, the devices use the transport layer to connect the sessions. And the network layer enables the devices to reach each other. So our main focus here is in the network layer. In our network layer, we have the network layer protocol, which is called IPv4, okay, Internet Protocol version 4. So this Internet Protocol version 4, in a short, we call IPv4, is the most widely used version of IP. Only the layer 3 protocol used on the internet, and this is our focus for this course. And the Internet Protocol version 6 is developed and slowly being implemented. So actually, it eventually replaced the IPv4 due to the limitations of the shortage of IPv4 address. And for this IPv6, they will have a different characteristic compared with the IPv4. So the whole chapters I'm going to explain about the IPv4 and also IPv6. That will be our focus for today. And whereas for the legacy network layer protocols such as Novell's, Appletop for the Macintosh operating systems, we have the connectionless network services, and so on. So these are the characteristics of IP. The first one, we are talking about the connectionless. There is no connection is established before sending the data packets. The second one is about the best efforts, which is called unreliable. No overhead is used to guarantee the packet delivery. And the third characteristic, we talk about the media independence. So it operates independently of the media carrying the data. So I'm going to focus one by one and explain each of these characteristics. All right, the first one. The first characteristics of IP protocols is connectionless. So what is the meaning of connectionless? So assuming that I'm using this analogy to explain about the connectionless. Now I have the letter to send it to you, so I am the sender. So sender doesn't know if you present at home, okay? If the letter arrive at the destinations, or if the receiver, which is you, read the letters. So the receiver also doesn't know when it is coming. So it's the same concept when you apply it into our network's terms. All right, let's talk about the second characteristics. Now, the second characteristics is the best effort protocol. Okay, IP is the best effort protocol. However, it is unreliable. Now, unreliable means that the IP does not have the capability to manage and recover from undelivered or corrupt packets. That means when I send the packets to the destinations, the IP will not going to have the recovery. Now, due to all this, it will cause a low overhead. Now, when you have a low overhead, of course, the packet can reach your destination in a very fast ways. That's why this is called best effort protocol. okay, even though it's not reliable. So this media independence operates independent of the layers that handle the physical medium that carries the packets. Okay, so this media independence also concerned with the size of the packets, which is we call it maximum transmission unit, MTU. So the MTU is established as part of the communications between the data link and the network layer, and it will have the fragmentation. At these times, an intermediary device, which is the router, will need to split up a packet when forwarding it from one media to a media with a smaller maximum transmission unit. So for example, copper cables MTU size will be 1518 bytes. And if you are using the copper serials, your MTU size will be 512 bytes. That means when you use the copper series, the maximum transmission unit, especially when you use a friend relay, is just you allowed the maximum up to 512 bytes only. And if you are using the fiber optic, of course, ATM for MTU, okay, protocols, you can allow for 17,966 bytes. And if you are using the wireless, which is Adult 2.11, your MTU size will be 2,272 bytes. So this will be the standard measurement for your maximum transmission unit when you want to travel from one source to the destinations. Depends on the media, the types of the media that you are using. Okay, then for the packaging of the transport layer protocols, so the transport layer encapsulations will happen. The original data will be here. Okay, so this is the original data. And transport layer will have to encapsulate the segment of the header, assuming that now is using the TCP protocols. And when you reach to the network layer, transport layer PDU will carry down, okay? And for the network layer encapsulation, it will encapsulate its own header, which is called the IP header. In this case here, your network layer of the PDU, the whole thing is called packets. So when the encapsulation happens. So when I use the IPv4 packet header, inside here we'll have the versions. And these versions will identify whether I'm using the IPv4 or IPv6 protocols. I might have a differentiated services. Okay, what type of services that you have. You will have the time to live as well. It's set to 10. That means you only have 10 chances to hop to any of the routers before it reaches to the destination. Okay, this is to avoid the looping happen, because sometimes it's due to the human error. You configure the destination wrongly, right? So in order to avoid the router keep on bouncing, hopping from one router to another router endlessly, so you need to have a time to live. So this TTL, when you reach to 0, the router will drop the packets. Okay, so that's the functions of TTL. And then we have the protocol. We also have the source IP addresses. We have the destination IP addresses. Okay, so all these are in the IPv4 packet header. And when we talk about the IPv4 header length, which is the one that highlighted in the white color, you have the IP header length. So this is under the IPv4 header fields. You got the total length. You will have the header checksum. You have the identifications. You have the flags. You have the fragment offset, and you have the protocols. So all these highlighted in the white color here is called IPv4 header fields. All right, let's study about the IPv4 packet header. So for this packet header, you have a type of service, which is consists of 8 bits of the fields. And it will have a different priority. You can set a different priority to your message, to your voice call, to your video, and so on. You can even set the priority to serve the voice call first, okay, and the rest will be on video and so on. Okay, so that will be the IPv4 packet headers inside this type of service. And you also have the flag and also the fragment offset, whether you want to turn off your fragments if you have a very less packets to carry on. And you have the maximum numbers of hops before undelivered, okay? And you have the protocols, which is the upper layer protocols, consists of TCP or UDP. So from the upper layer, which is a transport layer, pass down the information for you, your protocol in this field here will able to identify whether you are using the TCP protocols or the UDP protocols. And for your source address, it will identify the 32 bits of your source, your original. Where is the original source IP addresses? Where is these packets comes from? And they will have the destination address, okay, to identify where should you route the packets to the destinations. So this information will store 32 bits of the binary value for your destination of the packet. All right, there is a limitations of IPv4 addressing. The first issue is IP address depletions. If you are aware, nowadays everybody is holding many devices. You come to the lecture, you might have the iPhone, you might have the iPad, you might bring your laptop. So each of individual of us, we have more than 5 devices. Okay. Now, because of that, with the massive population in this world, plus the devices that you have, every of the devices times your populations in this world, they need to have a lot of IP addresses. That's why your IPv4 address can only cater for billion. So it's not enough. So that's why the first issue is IP address depletion. The second issue is we are facing right now is the internet routing table expansions. Now, due to the limitations of the IP addresses, we will encounter the routing table expansions. Too much ready to store your routing information because you are using a different devices to check your emails. Okay, maybe I send the emails to everybody. So you have 5 devices to check the emails as well. Okay, so it will cause the internet routing table expansions. And the third issue will be a lack of end-to-end connectivity. So that's why, due to these limitations of IPv4, they introduced the IPv6. So the IPv6 can increase your address space, can solve the problems of improve your packets handling, eliminates the need for network address translation. That means you no longer have to translate your network address from the public to private or from the private to the public address. Of course, the IPv6 also can have the integrated security. Now, if we compare IPv6 with IPv4, IPv4, the maximum numbers can support IP addresses is only 4 billion. But when you have the IP version 6, it can go up to 340 undecillion IP addresses. That's why when you use the IPv6 address, you don't have to do the subnetting, you don't have to do the VLSMs because the IP addresses is huge. It's more than enough. 340 undecillion number. Oh, that is huge. I can't imagine how many zeros I should write. Okay, so that is how IPv6 overcome the IPv4 IP addressing. Now, let's do the comparison between the IPv4 header and the IPv6 header. The one that labeled in this yellow color, it stands for field names kept for IPv4 to IPv6. That means it's the same. You have the versions. IPv6 also will have the versions. IPv4 got source address and destination address. IPv6 also will have source address and destination address. And when you have the IPv4 address labeled in a gray color, and this gray color means that it is not kept in IPv6. So you can see here, there's no gray color for the identifications, for IHL, for flags, for fragment offset, for header checksum, padding, and options. Okay, so that's how you interpret this IPv6 header. And inside here, we have this color called traffic class, payload, and next header and hot limit. That means all this is when you do the matching from IPv4, the name change. Okay, so that's why I represent it with this green, light green color. And if you can see here, the dark green color, this is the floor level. That means it is a new field in the IPv6 header. Okay, so that's the difference between IPv4 header and the IPv6 header. Okay, this is the full screens of the IPv6 packet header. You have the versions, you got a traffic class, you got a floor level, you got a payload length, you got a next header, you have the hot limit, and of course you have the source and destination IP address. So this is the packet header for IPv6. So these are the examples of the sample for IPv6 header if you use the Wireshark okay, to capture the packets. So you will have SAM, you got the numbers, you have the time, you got the source IPv6 address, you have the destination IPv6 address, you have the protocol, then you have a LAN, then you have the information and so on. And from here, they will have an Internet Protocol version 6, and should be able to identify your source IPv6 address and destination IPv6 address. Now, if you understand about the sample of IPv4 header in using your Wireshark, there is no problems for you to analyze the sample of IPv6 header. Just the differences is that IPv4 is using the decimal numbers and IPv6 is using the hexadecimal numbers. Let's continue our session for 6.2, routing sessions. Okay, now when you look at the topology given here, they will have circle for yellow color. Okay, one circle, which means this is one broadcast domain, and another circle is another broadcast domain. So whatever the computer's devices, which is PC1 and PC2, in this circle here, they belong to the same subnet, which is 192.168.10.0/24. And the remote networks here will be another different networks, okay, which is route to the internet. Now, assuming that PC1 and PC2 would like to route to this network here, so they have to pass by the default gateway because they are not belong to the same network, okay? So according to the theory, you need to configure a default gateway, okay, which is in the router that connected to this network. So in this case, the router that connected to this network, the interface is this one, .1. So this .1 means that you pick up the network address 192.168.10. And this interface is .1. Okay, so that means your router 1, the default gateway have to configure 192.168.10.1 so that when you have the gateway already, PC1 and PC2 can able to carry the default gateway, okay, to route to the remote networks if you configure a default gateway. Okay, so that's how the topology explained. Okay, so when you move on to next slide here, IPv4 host routing table. So if I want to look at the PC1, okay, I look at the PC1, I go to the command prompt, and then I type the configuration command, which is the netstat _r. So it will give me the route table. Okay, so they will have active routes for the destinations. I got the network destinations. It will list out all the network destinations, all the net masks. Net mask means it's a subnet mask. And then it will list down all the gateway, and it will list down the interface, okay, the specific source IP addresses that connecting to that particular network destinations, and it will list down the metric, the duration for me to route to the destination. Okay, let's move on to the next slides. So this is the examples. If I want to route to the destination of the network destination address, which is unknown, okay, so it's 0.0.0.0, that means I can route to any of the IP addresses set by default. So this is the default network, yeah? And then you have a default subnet mask, which is all turns to 0.0.0.0. That means I can route to any of the network destinations with any of the subnet masks, provided my default gateway will be 192.168.10.1, which is here just now. Okay, I can route to any of the networks after this. Okay, so the interface that connecting to me, which is the source IP address, is from 192.168.10.10, which is this device. Okay, 192.168.10.10. And the metric for me to route to any of the destination here, okay, will be 25. So that's how you interpret this routing table. Okay, next is about the IPv6 route. Okay, if you want to route to this netstat again, you have the command for netstat _, and then you got -r. Then you also preview the IPv6 if you have the IPv6 configured, and then you will have the route and you have the gateway. All right, you have the destination for IPv6 and you have the gateway address. So that's the samples of IPv6 host routing table. Okay, so how the router packet forwarding the decision made? Okay, so assume that this is the router 1. You have the router 1 here. router 1 is directly connected to this network, which is 192.168.10.0. Router 1 is directly connected to this network, which is 192.168.11.0. Router 1 is directly connected to this network, which is 209.165.200.224/30. That means in the router 1 perspective, there will have 3 networks that is directly connected to the router 1. Okay, that's how you analyze this topology. Now, from this purple color here, okay, in these purple colors here, I got 2 networks that directly connected to the router 2, which is 10.1.1.0 and 10.1.2.0. Now, from the router 1 perspective, when the router 1 look at this network of 10.1.1.0/24 and 10.1.2./24, it is the remote networks. Why? Because these 2 networks is not directly connected to the router 1. You have to pass by this router 2, then only can directly connect it to the 10.1.1.0 and 10.1.2.0. So in this case here, in the router 1 perspective, the one that circle the purple color here, this is considered as the remote networks for the router 1. Okay? Now, let's look at this example. Okay, it's the same example like just now previous slides. Okay, I have a router 1 here. And the router 1 is directly connected to the 192.168.10.0 network. Router 1 is directly connected to 192.168.11.0. And router 1 is directly connected to 209.165.224/30. So you have 3 directly connected networks. Now, in this case here, router 1 will have 3 C. Okay, connected means is denoted as C. So you will have 3C. So it is 1, 2, 3. So what is the first C? 192.168.10.0, which is here. 192.168.10.0 is directly connected and is connected to the gigabit 0/0. So you can see here it's directly connected to this network and it is using gigabit 0/0. And you have another C, which is here, 192.168.11.0 is connecting to 0/1. So that's why when you go to the router 1, you show route, the IP addressing can tell you, in order for me to route to 192.168.11.0, I directly connected to the interface, which is gigabit Ethernet 0/1, which is representing this network. Okay, let's move on to here. Now, router 1 is directly connected to this network, 209.165.224/30. That's why you have another C here, 209.165.200.224/30 is directly connected to your serial 0/0/0, which is here. Okay, so that is how you interpret 3C, okay, in the router 1. So from the router 1 perspective, router 1 do not have the direct access to the 10.1.1.0 and router 1 do not have the access to the 10.1.2.0. So in this case here, router 1 is interpret this as the remote network, okay, and router 1 will interpret this 10.1.2.0 as a remote network. So from the router 1 perspective, in order to route to these 2 remote networks, it will be using the distant vector routing protocols. So in this case here, the distant vector routing protocol is denoted as D, which is using the EIGRP routing protocols. When you show IP route, it's already proven that this router 1 already have a pre-configured of the EIGRP protocol, which is denoted as D. So if you look at the D here, they will have route to the 10.1.1.0 remote networks, okay, which is this network, 10.1.1.0/24 to the remote networks, is using the routing protocol called EIGRP. And the first value here for the after the bracket, it will be 90. So this one stands for the administrative distance by default. When you use the EIGRP, will cost you for 90. And the next value here will be the metric to reach to the destination of 10.1.1.0/24. So via the 209.165.200.226, that means in order for me to route to this network, I have to pass by the next hop router, which is in these IP addresses. So if you look at the diagram here, router 1 want to route to this network, you have to go to next hop router, which is this interface, and this interface is the IP addresses is 209.165.200.226 to route to this network. That's why your VIO is 209.165.200.226. Okay, now same goes to the second network, which is 10.1.2.0. You have the same administrative distance because you are using the same protocol of EIGRP due to the denoted of D. And then the matrix will be these numbers via the next hop IP addresses. Same thing, you hop to these addresses, this IP address, in order for me to go to this way. All right, and the duration is 5 seconds as well, and pass by the serial S0/0/0. Now let me draw the broadcast domain for the router R1 and the router R2, so that easily for you to identify which one is the directly connected networks and which one is actually the remote networks. Okay, now according to these examples here, router R1 is directly connected to this network. So this is one network. Router R1 is connecting to here. This is second broadcast domain. R1 is directly connected to 209.165.200.224. R1 is directly connected to these three networks. Okay, so that's why there will be a C, right? Now for the router 2 will have this one broadcast domain, and router 2 will have this one broadcast domain. Now, if we zoom in to the C and L, what is these examples? Assuming that I just pick up the 192.168.10.0, that means I just look at this network as my example, yeah? Okay, now you will have the C and L. Now, just now we know that from the C represent the connected. That means your network address, which network is directly connected to your router 1. So in this case, you have 192.168.10.0/24, which is proven here. Okay, is directly connected, and you are using the gigabit Ethernet 0/0, which is this interface. Okay. Now, for the local means you have 192.168.10.1/32 is directly connected. So this 10.1 is the IP addresses of your network, 192.168.10.0. If you look at the circle here, I refers to the specific IP addresses of my interface here is .1. Can you see this .1? So that's why my address will be 192.168.10.1/32 is directly connected and through the interface of G0/0. Have a look of this, G0/0. So that will be the directly connected network and also the interface. Okay, so I repeat, directly connected networks, when you show IP route, it will denote it as C. Directly connected IP addresses, for that interface, it will denote it as L. Okay? So let me conclude what you have learned based on the previous slides. Okay, first of all, you need to circle the broadcast domain. This is one broadcast domain, this is second broadcast domain, this is the third broadcast domain, and this one is fourth and fifth. Okay, so you have 5 broadcast domain in this topology. Okay, so the first value here, the first value is the green colors, D. Okay, so for this D here, according to the examples, in order for you to route to 10.1.1.0, if you look at here, if I'm from the R1 perspective, I have 3 networks directly connected to the R1, and these 2 networks is actually the remote networks, which is 10.1.1.0 and 10.1.2.0. So in these examples here, I just pick up this network only, okay, to understand, to analyze the whole situations. So in order to route to the 10.1.1.0/24, router 1 need to have a protocols to route to the remote networks. And this protocol is called EIGRP. So this EIGRP is under the categories of the distance vector routing protocol. That's why it's denoted as D. Okay, so the first value here is to identify how the network was learned by the router. Okay, so how to interpret the second value, the yellow color here. So this yellow color is represent your network address, the destination network that you want to route to. So in this case here, Router 1 want to route to this network 10.1.1.0/24. And the third value here highlighted in the pink color, which is identify the administrative distance, which is the trustworthiness of the route source. And the value besides this administrative distance is highlighted in the blue color, light blue. So if you refers to here, this light blue is identify the metric to reach the remote networks via, okay, you will have another orange colors here, 209.165.200.226. So it will identify the next hop IP addresses to reach to the remote networks. The 5 here means that it will identify the amount of elapsed time since the network was discovered. Okay, and the value for this gray color, serial 0/0/0, it is to identify the outgoing interface, the exit interface to reach to your destination network. So from these slides here, it should be able to tell you in order for the router 1 to route to this remote network 10.1.1.0 and 10.1.2.0, don't forget these two is the remote network of router R1. That's why you have two networks here is denoted as D using the distant vector routing protocol. Okay, you need to have a routing protocol to route to the remote networks. And then they will have a SAN metric because the EIGRP will have the SAN value 90. And you'll have the same metric via the next hop is the same, and the duration is the same, exit interface also the same. Okay, so you have here for the router R1, your next hop is the same, exit interface is the same, in order for you to go to these two networks. Okay, so we will move on to the section of 6.3, the router. Okay, what can you understand about the router? Now, the router also is a computer, because when you disassemble the router, you will know that inside there, they also have the random access memory, they also have a ROM, they also have the NVRAM, they also have the flash. According to these slides here, we have the running IOS, we will have the running configuration files, we have IP routing and NRP tables and the packet buffer. Now, all this is temporarily stored in the random access memory. So that means that for your running IOS, all this running configuration file and so on, if you didn't save it into your random access memory, when you switch off your power, you turn on back, all the configuration will disappear. Okay, so because all these files is temporarily, is a volatile stored into your random access memory. Okay, so for your boot up instructions, your basic diagnostic software, the limited inter-network operating system, the iOS versions, so all these three is stored in the ROM. Okay, ROM means it's non-volatile. Even though you switch off your router and you turn on back, all these three configuration is still there. Okay, so all these three functions is stored in the read-only memory. Now for your startup configuration files, the startup configurations, you store it into the NVRAM. Okay, so NVRAM is stand for non-volatile random access memory. And another two for your iOS, okay, the latest iOS, you can upgrade the latest versions. So what's the difference between this and this? This is limited iOS, whereby you can't able to delete because it's already fixed program inside there. Okay, there's a limited iOS as the basic iOS to run the router configurations. Where else for the flash, you will have the inter-network operating system, you will have the other system files. So this iOS, you can upgrade anytime that you want. You just have to wipe off your current versions and you upgrade it into the newer versions when you use a flash card. So all these two files here is stored in the flash memory. Okay, so this is called non-volatile. All right, so inside a router, you can see all these, okay, all these components. And you will have the router backplane. Okay, when you have this type of model, your router backplane will have the double wide EHWIC slot. You will have a 4 GB flash card slots, and then you have all these interface. So you have a serial interfaces and also the LAN interfaces. Okay, so when you boot up your routers, you go and show version, you will see that all the files labeled with the Cisco iOS software, what is the versions, and then what type of the versions model, the versions number and the release software. Then will tell you the technical support. You can contact this Cisco.com, and then ROM here you will have what type of a ROM versions that store into the ROM, and then you also have the flash memory. Okay, system image flash, and this one is the revision with what type of the memory here. Okay, it's a Cisco's this model, the revision of 1.0. And you also have an interface to tell you that they will have a 2 gigabit Ethernet interface by default, 2 serial asynchronous interfaces. You have a 255K bytes of the non-volatile configuration memory, and you have all these into your compact flash read or write. So that is how the information of your memory, you have the ROM, RAM, NVRAM, and also the details of the flash info will preview all inside here when you show version. So let's move on to next section, 6.4, configuring a Cisco router. So how to configure? I believe that you already learned from the previous sessions how to set up the router configuration. So the first command, you can go to the router, assuming that I'm configuring the router R1. Okay, so by default, it's given you the user prompt here is the router. Okay, so you type the enable. So it will prompt up with the privileged executive mode. So you are in this privileged executive mode, you can configure your interface. So you type configure terminal, then it will come up with this global configuration mode, and you can type this command hostname R1. So when you type this hostname R1, it will turn from by default the router to the R1 level. Okay, so based on this command. That's all. That is how you rename your hostname. So if I want to set up the password for the enable secret password, so that means when I press the enable, it will prompt me with the password first, then only I can able to use the next steps, which is to configure my configurations. Okay, so that's why in order to protect my router, I need to set the password before it can directly configure anything into my router. So I have to set up the enable secret password. Why is it secret? Because I'm going to encrypt my password after I set up the enable password. Okay, so that's why the command is for you to put enable secret class, and then you will have a line console 0 password Cisco login exit. Okay, so that is how you configure the line console 0, and the line VTY04 is for you to configure the VTY password. Okay, service password encryption means you're going to encrypt both of the password. Either it's a line console 0 or the line VTY04. And for this part here, we're going to have configure the banner MOTD. So the banner MOTD is something like, okay, if let's say you first time log into the router, they will have a welcome message. So that is what we call banner. Okay, so banner message of the day, MOTD, stand for message of the day. So you can just enter any of the message of the day. Okay, but if you start with the hash sign, you have to end with the character of hash sign. If you start with the alias, you have to end up with the alias. If you start with the ampersand, you also have to end up with the ampersand. So in these examples here, I'm going to set up my banner MLTD. So I will write this asterisk command, and then I will have a warning, unauthorized access is prohibited, and I put the asterisk again, and I end it with my hash sign because my beginning, I started with my MOTD H, and now I end it with the hash sign. So that's how I set up my banner MOTD. And then the next one is I want to save all the configuration that I configured earlier on. Then the command for me to save it into the startup configuration, all right, which is the NVRAM, non-volatile random access memory. So I type the words command of copy, running config, and startup configuration. So when I do this, I'm moving my running configurations, which is from the RAM, to the startup configurations, which is from the NVRAM. So that even though when I restart my router, all the previous setting that I have for the configuration is still there. So that's the reason I copy running config, startup config. Okay, so here I do the basic configurations of my router. I want to configure the interface of G0/0, this interface, and I'm going to give our IP address of 192.168.10.1. Okay, here, IP address 192.168.10.1, and don't forget to write your subnet mask, which is 255.255.255.0. How I know? Because this is /24. So /24, you have 24 ones. So when you convert it into the decimal, you will get 255.255.255.0. And after that, don't forget to bring your interface up by issue no shutdown. When you issue this no shutdown, immediately you will see that you have the message prompt up with the interface gigabit 0/0 changes stat to up. So line protocol of the interface for gigabit Ethernet 0/0 change stat to up. Okay, just by issuing this command. So when you finish your configuration for your directly interface, you put a no shut to bring the interface up. Okay, so once you have done, you type the word exit, you repeat the same steps for the interface giga 0/1, you enter the IP addresses, you issue the no shutdown, and again, it will bring your interface up. Okay, so this is the examples for me to configure this interface and this interface, these two interfaces. So let's verify it. To check whether our configuration command is correct, I'm going to type show IP interface brief. So when I type the show IP interface brief, I will get my interface, I will get my IP addresses, I will get the status whether it's up or down. So when it's up, congratulations, your configuration is correct. All right, we have done all the sessions, so let's come to the conclusions. Now, from your 6.1 sessions, the network layer protocols, you already learned about the network layer or OSI layer 3 that provide the services to allow end devices to exchange the data across the network. And the IPv6 simplified the header offers the several advantages over the IPv4. So this IPv6 can able to give you the better routing efficiency, simplify the extensions headers. IPv6 also have the capability for the per floor processing. So these two you already learned in the network layer protocols. And the second sessions, you learn about the routing. So the routing table of the router stores the information about directly connected networks, which is denoted as C, and the remote routes, which is denoted as D, because we are using the distant vector routing protocols. And from the example given just now is the EIGRP protocols. And then we'll have another one, which is the L, local, stand for directly connected interface IP addresses that connect to your router. Okay, so you also learn about this. If the router has an entry in its routing table for the destination network, the router will forward the packets. Okay, if no routing entry exists, of course, the router may do the following. The first, it will forward the packets to the default routes. But if you don't configure the default gateway, the router cannot find the destination address. So in this case, it will drop the packet. Okay, so that is you learn about the routing. Okay, so for the 6.3 routers, in order for the routers to be reachable, the router interface must be configured. So you know that we do some configurations, you have to configure these IP addresses, you put the IP addresses, you put the subnet mask, you have to issue no shut. So all this is the configurations done by the routers. So don't forget, routers is behave like a computer. So you also learn about the volatile and also the non-volatile memory, such as RAM, ROM, and VRAM, and flash. Okay, so how do you configure the router? You also learn about the basic configuration, how to rename your hostname, how to set up your password in your line console, how to do your banner MLTD, how to save your configuration, what is the command for you to save your configuration in your router, so that when you shut down your router, you turn on back, your configuration is still there. Okay, so the next sessions, you also learn about configure the LAN interfaces. How do you set up the IP addresses, default gateway, subnet mask, and bring the interface up. And the next thing, you verify the configuration command to check whether your configuration is correct or not. So you identify by show IP interface brief. So if you get all the interface is up, congratulations, your configurations all is correct for your router R1. So you have learned these sessions all together. So we have concluded this lesson. Thank you everybody for watching. So please subscribe to my YouTube channel for M tips if you like this video. Thank you.